Okay, so let's talk conics today. So I didn't draw that pretty of pictures, but I found this really pretty picture online. So it shows a circle that if we cut it straight across, it'll be, two cones, inverted cones. If we cut it straight across, it would be a circle. If we cut it as an angle, it would be an ellipse. If we cut it as an angle, check this one out. This is cutting it as an angle. Isn't it still an ellipse that just got cut in half? Like if we were to continue going, wouldn't it continue and be an ellipse if the cone was longer? It doesn't. But if we did, if the cone was longer, as long as it needed to be, it would eventually be an ellipse. So a parabola is just half of an ellipse. Are you ready for it? I got more. I do always have more. A hyperbola. A hyperbola is when you slice a cone straight through, top and bottom. But what if, now just envision those pieces. What if I took the cone, snapped it in half, and then took the open ends of the cone and put them together? You'd have an ellipse. Okay, I'm going to say it again. If I were to split this cone in half, right here, like I had two ice cream cones, right? Two ice cream cones. And I took the two ice cream, okay, there's too much talking. And I took the two ice cream cones and I put them together, met them together, right? So that they looked like this, right? Wouldn't I have had an ellipse in there? So a hyperbola is really an ellipse only turned away from each other. The parabola is just half of the ellipse. And the circle, I'm going to argue, is just a special ellipse. They're all ellipses. I'm going to show you. I wonder if it would work if we did this. Let's take a picture of this. No, that's not what I wanted. I do. Let's do it this way. What if I took this? By what? How am I changing it?
Shortening your
I'm shortening the Y. Why couldn't I do it with the X? You could. Depending, okay, Florency, I'm going to answer your question. Check this out. What if it was originally like this? Wouldn't I shrink the X? Make it bigger. No, it's still the X. I'm still just manipulating the X. Right? So could you argue that all conics are pieces of ellipses? Totally. All right, let's do it. All right, so students will discover the formula for an ellipse and a hyperbola. All right? All right, let's think outside of the box. Can you match details of the graph to components of the equation? So here's the graph. Here's the equation. You guys figure it out. Okay, so Michael, can you match a detail of the graph to the equation? The x squared over 49, we could say it was 7 squared. What about the 7? Okay, it's one of the points on, so if we start at the center and we go out 7, it'll be a point on the ellipse. Good. And we could go in the opposite direction also. I don't need to write -7 because distance is always positive. Right? And I'm talking about the distance from the center out to the ellipse. Are you excited yet, guys? Not yet. Christopher. Hold on. Not yet. Christopher. Can you tell me another detail of my graph that matches a component of my equation? The 4. If I took, which is really 2 squared, and if I took the square root of it, I would get 2. Exactly. What is what on my graph? It's my change in y, right? I would argue that it's not my p, but I could get my p from it. You could get, because it's all relates. Unfortunately, p goes to the focus, and we're not going to take this as far as going to, because let's see. Do I really want to do this? No. I don't. We'll wait to the end. I could tell you what p is right now just by looking at these two numbers. Subtract them. So 49 minus 4 would be 45. So the square root of 45 would be my focus. No, it's not just because. It always works that way. It's not just because. It always works that way. If I subtract these two numbers and square root it, I would have my p. Always. Your p or your focus. Because your p is the distance from your vertex up to your focus, right? And your directrix. So technically, if I had it right here, then it would be also on the opposite side here, right? If it was a parabola. Okay, let's just keep going, because we're not getting that deep in this step at all. We're not going to go that deep into. See, now I would argue that we're going deeper than that, than telling you the formulas on how to figure that out.
Oh, yeah, you have to understand it.
You have to understand it all. Me just mentioning it isn't enough, and me just giving you a formula on how to figure it out to me isn't enough. I'd much rather you guys look at this stuff and just see all kinds of connections. Okay? Okay. All right. So that's an ellipse. I think you guys could look at that one really quickly and tell me how that would. Okay, good. So if I was to look at my x, it's going to be a change in 3, which is correct. And on my y, it's going to be a change of 7, which is correct. Okay, I'm going to show you one more piece. What do we normally see, like in circles? Didn't we see parentheses up here? I'm going to rewrite it. I'm going to rewrite it right here. Normally we'd see it like this. Why am I putting zeros in there, folks? Because it's at 0, 0. I have a center of 0, 0. All right, thumbs up, thumbs down. How are we doing? You're just reading it. But I'm telling you, that's not the way it's normally taught. Okay, good. Keep going. Okay, now I'm going to give you the graph, and you write the equation. Go. All right, I'm going to cold call. Sydney. Cold call. Sydney's not here? Parsa. Where's Parsa? Parsa. Parsa, can you tell me anything about this at all? Okay, I'm waiting for everybody, please. It's x minus 3. Can you tell me why it's x minus 3? Because I'm shifting to the right 3. Good? How about Lorenzo? Y plus 2? Can you tell me why it's y plus 2? Because it's shifting down or translating down to. Perfect. Excellent. What about Christina? Christina. What next? Another piece? You put 3 squared? 3 squared or 9. And so let's check, because this is 3, correct? Let's see, what about Philip? It's 4 squared, or 16. Thank you. Kids are so smart. You don't have to put it at 4 squared. You can put it at 16. Okay? All right. Thumbs up, thumbs down. Do we need another one? We're good? I mean, that one, this number, I'm going to go quick. This number would be 2 or 4, 2 squared, which is 4. And this number would be 1, 2, 3, 4, 5, 6. So this would be 36. We're shifting 1, 2, 3. I should be doing it with my pen. 1, 2, 3, 4. We're shifting over 4 on my x. So it's x plus 4. And we're not shifting at all on the y. Y minus 0. All right, moving on to the next one. Okay. Okay. It's a hyperbola. Okay. I'm not even going to tell you what everything is. I want you to figure it out for yourself. So it is one, hold on, let me show you. I'm just going to tell you some details, some descriptors. All right, here, this is called a branch. This is actually, let me make it a little bit darker. This is actually your graph. That is your graph. That is a hyperbola. This is the other side of the hyperbola, or the branch. The branch touches right here, which we would call that our vertex, which would make sense. It's like a parabola, right? And it's this distance. So where do you think its focus is? This would be it. We're going to talk about it in a second. This would be the directrix. Then where would the foci be? There's 2. So if this is 3 away, what's P? 3. Then this would be 1, 2, 3. Right? It would go out, right? It doesn't exactly fit this way because of this right here, our asymptote. But anyways, all right, we're not going to even concern ourselves with that. This is our vertex. So I have 2 vertices because I have 2 separate hyperbola, right? Or I guess it's not 2 separate. It's one hyperbola with 2 branches, right? It's a hyperbola because it's cutting through inverted cones, so it makes 2 branches. Okay, let me show you what this is. I call this, I don't want to give you the name yet. I don't think I'm going to give it to you. I think I just want you guys to think about it for a second. Okay, I call this something because it directly relates. That's why it's there. But I don't think I'm going to make it dark. I'm just going to leave it like that. And notice these are dotted. And when things are dotted, what does that mean? They're not really there, but they're having an effect on the graph. They're like boundaries is exactly what they are. They are boundaries. Okay, so you guys talk. I'm sorry, I should have said this, guys. So match details of the graph. There are details of this graph. Match those to the components of the equation. This is the equation of a hyperbola. Specifically, that hyperbola right there matches that equation. Notice the only thing different from the ellipse is it's a minus sign instead of a plus sign. It's the only difference. Okay? It makes a whole, we're going to argue that one too. All right, did you guys figure it out? I've got Dustin. Dustin, can you give me one detail of the graph that matches a component of the equation? The 9 is how far the vertex is out to what? From the origin out to on the x-axis or the y-axis? On the x. So I got 9? 3. Good. So this is 3 squared. I should change it. So this should be 3 squared, which makes this distance 3. It's going to be a lot of stuff in there, right? Okay, what about Kayla? Give me another detail of the graph that matches a component in the equation. So not square it, but square root it, right? It's 2. Good. So it goes this much on the y. I should not do that. Okay, too much talking, guys. It's my turn. All right. I think that's all we need. Did somebody figure out how we find these branches right here? How do I graph those branches? Because of the asymptotes, right? Well, where did I get the asymptotes from? I heard it. Slope. Right? So do you want to know what my box is called? No. It's a... No. It's got the word slope. Box. Slope box. Yes, I'll do it. All right. Yes. Okay. We'll gather the candy in a minute. All right. 5, 4, 3, 2, 1. I'm waiting for Lorenzo to erase his picture. It's got a hyperbola in it, though. Okay. So I call it a slope box because if I know the slope, which is my rise is 2 and my run is 3, I can actually do my rise and then my run and look at, there's the slope of that asymptote. Or if I go up and over, that's a negative slope of up 2 over 3. But you don't really have to know the slope, or in the other class last year we had to actually give the equation of the asymptote. We're not going to go there either. All you have to do is draw, hold on. You guys, I feel like I'm back to the future in 7th grade. Yes, I said asymptote. Okay?
Is it asymptote or
Asymptote. Oh, we are just loving this. Asymptote. Oh, okay. Well, the last class I heard, you know how they think I can't hear all the time? She said asymptote. You guys are silly. You're always going to be in high school, right? All right, 5, 4, 3, 2, 1. So as I'm doing this, I would say, well, I'm going up 2, down 2, out 3, and then I can draw a box. And once I have a box, I can draw an asymptote through the corners of the box, right there. Then once I have asymptotes, I can draw branches that skim the asymptote because they're never going to touch because it's a boundary, and it goes right through the vertex and comes back out. I'm going to argue one more thing. I think I'm going to take a picture of this, guys. I know you're super excited about Conics. Who loves Conics? Check this out. Let's take a picture of this. Hold on. Give me a sec. Okay, it's not going to be perfect because I drew it. It's not going to be perfect because I drew it. But I would argue that if I were to take that branch And you guys can't wait to see what I'm going to draw. I love it. And go this way, right? No, it would end up being an ellipse. It's just my graph is off, right? You understand the shape? It is. It's a lot of colors. It's overkill, right? Okay, let's look at, like, you could use the same slope box if this was, what was the equation? Oh, wait, I know. X squared over, how much did we go over on the X? 3, so it would be 9. If I were to change this to a plus, X squared over 4, it would look like this. Right? Because an ellipse has a plus sign, and a hyperbola has a subtraction sign. Hold on, wait for it. I'm almost there. Wait, we got to come back to that one. We seriously got to come back to that one. All right, I need to group it. Oh, here's the group. Group it, and then copy it. Copy, paste, then ungroup it. I'm almost there. I forgot 1 equals 1. Only this one is negative. Okay, so on the fly, that's what happens. It takes a little bit of time. So if it has a negative sign, the branches are going away from my slope box. If it has a plus sign, it's got the same shape. It's just contained inside. Oops, wrong color. Inside of my slope box. Aren't they directly related with each other? Yes, Allison. I can't, it would be Y. Thank you. But it's stuck now. This, I'm in the red? No. It's got to be perfect because this one is the one we're going to have. Thank you. Ungroup. Make it Y. Thank you, Allison. All right, moving on. Thumbs up, thumbs down. Do we know everything we need to know about hyperbolas and ellipses? Okay. So what's the difference with this one? Take a look at it for a second. Okay, yeah, let's discuss it. You guys discuss it, then tell me the details. I'm going to pause it. All righty. So I would say this is also a hyperbola. Here are your branches. I heard slope box. Slope box is bigger. By how much? So we're going to go out. We're going to go out 4. So check that it's over here now. Why is it over here? Okay, so not tilted, but it's now orientated on your Y instead of on the x-axis, right? We're graphing on the Y. So my Y would be 5. So my slope box would be up 5 over 4, up 5 over 4, down 5 over 4, down 5 over 4. Draw my asymptotes, and my branches need to be on the y-axis because we're talking about y now. Let's ask ourselves something really quick. If we were to talk about an ellipse, and I switched it, where I put y squared over 25 plus x squared over 16, would it change its orientation? Well, you notice that my y came first, and so now instead of it being like this, if I were to switch, say for instance, are these any different? Talk in your groups. Are those any? Okay, guys, show me with your response sticks whether they're the same or different. Green would be the same, red would be different. Are they the same or different? These two right here. Uh-oh. These right here. Are they the same or different? Okay, Philip. Hold on. Okay, all right, thank you. So you guys are split. I said green means they're the same, red means they're different, right? Green for go, red for no go. All right. Okay, so more of us are green out. 5, 4, 3, 2, 1. Philip, I'll let you explain. The y squared is always above 25, so you're always going to go up 5. And x squared is always going to be out 4, and you're always going to make a loop, so wouldn't they both be the same? Then why would it be different if I put the y in front on this one? Because it's minus, right? So if it wasn't, but it's with hyperbolas, it's always going to be minus. So if the x is the one that's positive, then it's going on the x-axis, right? And if it's the y is the one that's positive, then we're talking about the y-axis. That's the only difference. Okay, let's move on. I'm excited. You guys are super excited right now, and you get me all excited. All right, so can we do one of these? Can you guys do this? Nice. There's my graph. I would argue let's do the harder one. Yeah. Let's do this one instead. All right, work with your groups and match the equation to the graph, please. 1. Okay, so I think most of you have this pretty much done. So we're talking about y first because we're looking at the branches are the branches, okay, I'm going to wait. Are the branches ever even going to touch x? The x-axis? No. So we are talking about y first. That's just too big of a line. All right, so we're talking about y first. How much is y shifting? Well, we had to shift down 1, 2, right? Let's do the x first. It works better. If we do the x first, the x is shifting. If here's the origin, don't I have to shift to the left 1? Because we're eventually getting here, right? So I have to shift to the left 1. So I'm going to go, my x is going x, not minus 1, but plus 1. I'm right here at the origin. I have to get to the center right there. So I have to go over 1, down 2. So we're going over 1, down. So we're going over 1, down 2. So when I go down 2, it's going to be y, not y minus 2, but plus 2. Now let's look at our slope box. How much am I going from, now here is the center, right? The center of my graph. How far am I going up to my branch? 1, 2, 3. This is going to be 9. And I'm going out to get to my slope box? 2. So this is going to be 2 squared or 4. All right. Yes. The only thing that determines which way they go is which one's positive. So actually the x's are negative, so we're not talking about the x-axis. The y's are positive, so we're talking about the y-axis. On this one, I need the talking to stop. I'm going to start keeping you after class because you are now wasting my time. Okay? So when it's this way, I'm talking about the x-axis and specifically going over 1 down 2. So I would be at x plus 2. The x comes first because the branches are touching the x-axis. Make sense? And then the y would be down. What are we going? Over 1. We went over 1. Why didn't anybody correct me? Allison, you're usually the one that corrects me, right? So it's 1 and down 2. So y plus 2. And then how much is my slope box going out on the x? 1, 2, 3, 9, and up 2, so 4. Yeah, it's just oriented differently. And if you made it adding, it would be this. Okay? If it was adding, it would be an ellipse. Okay, moving on. So I need you guys to write this down. I'm going to explain it to you for a second, and then you're going to write it down in your notes, and then we're going to do a couple problems really, really quickly. Okay? All right. So, conics part 1. I need everybody's attention. So this is what you're going to ask yourself. You're not going to understand the very last one. Just give me a second. X and y are both squared. So if I have something like this that says x is squared and y is squared, right? Yes, that means we would go here. No, if you had something like this, we would know that that would be a parabola, right? Because you only have one of them squared. That makes a parabola. Do x squared and y squared have the same sign? Well, if it's something like this, you would say yes, they have the same sign, and we go this way. If they have something like this, we knew it would be a hyperbola, right? Because there's a negative sign there. One of them's positive, one of them's negative. On this one, the branches are going to look like this. If it was this, my branches would look like this. Correct? And I know it's messed up, do x, should say squared, and y squared have the same coefficients? If they have the same coefficients, it's a circle. If they don't, it's an ellipse. And we're going to talk about that one right now. So I'm going to erase my messiness. And you guys copy this down your notes. Let me give you a minute or so. Okay, I will fix them then because they're messy. Okay. So Lucas still wants the examples. So we're going to say, if they're both squared, that's a yes. We'll do the green. X squared plus y squared equals 1. If they're not, it would be a no. How about like this? We'll do that. We'll make everything look the same. Do x squared and y squared have the same sign? This would be yes. They have the same sign. This one would be a no. We'll do this one first. X squared minus y squared equals 1 would look like this. What? And this would be y squared minus x squared equals 1 would look like this. same coefficients would be this. Different coefficients would be, Lucas, I don't want talking, I just want writing. And we'll get to this tomorrow. How about x squared over 4? I'll make the example like this for this one. If they were both 4, and we're going to talk about that right now, it would be a circle. But if they are different coefficients, it would be an ellipse. Pausing. All right, let's work with this. I'm going to go quickly. I think you guys can handle it because we just need to get through these examples. So I'm not going to give you time to talk. So let's just, everybody pens down, caps, ready to listen. Okay. So the only problem with this problem right here is that it's got a 16 and not a 1. So if I want to make it a 1, couldn't I divide by 16? Divide everybody by 16. So now I have, I'm going to change colors as I go, x minus 0 squared, 3, 2, 1. Okay, so I have x minus 0 squared over 4 squared. I have a plus, wrong color. I have a plus, and then I have a y minus 2 squared over 4 squared. So just like in the last screen, I ask myself, are they both squared? They are. So I know it's not a parabola. Do they have, what was the next thing? Do they have the same sign? Are they both plus? They're both plus, so it's not a hyperbola. Do they have the same coefficient? Now this is where this comes into play. So my center of my conic is going to be 0, 2. Because this is my horizontal shift and this is my vertical shift. So I'll be at 0 and I'm going to go up 2. Then I say to myself, how far out am I going on the x-axis? I'm going out 4. So I'm going to go out 4 from my center, 1, 2, 3, 4. And this way 4, 1, 2, 3, 4. Then I've got another shift of 4. Only this time I'm going vertical. 1, 2, 3, 4. 1, 2, 3, 4. And I don't really have an ellipse this time. I have a circle. How? Why do I have a circle? That's not the way you normally saw circles. And remember when I said to you in the very beginning, a circle is just a type of ellipse. It looks like an ellipse, only it's going up and down the same as it's going out. There's three more that are added to my list right there, just because you guys are right there in front of me. All right, so I'm going up 4 and I'm going out 4. Well, when I go up and out the same amount, I make a circle. When I go up the same amount and out the same amount, I get a circle. Would be the same, yeah. I'm calling it a coefficient because technically, isn't this really, this right here, isn't this really 1/16 of x squared? It's a coefficient. Okay? So that number that's underneath there is a coefficient. It's just in a fraction form. So if I were to change this to, let's say, we'll make the y a 9 underneath there, that would change it because now it would come down to here, 3 and 3. Then it would look like an ellipse. But since they're the same, you're going the same distance out and out. You could look at it as a circle, or you could look at it as a ellipse with a circular, it's a circular ellipse. A circle is an ellipse, but an ellipse is not a circle, just like a square and a rectangle. Right? A square is a type of special rectangle. It's exactly the same thing. All right, I'm going to move on. All right, so let's ask ourselves, is this a parabola? No, it can't be a parabola because they're both squared. Is it a hyperbola? No, because they're both positive. Is it a circle? No, because that's a 9, so I'm going to be going out 3 and 3, and that's a 16, so I'm going to be going up 4 and 4. So it has to be an ellipse. So, C, my center, is at -4, -1. So I'm going to go out -4, 1, 2, 3, 4, and -1. That 9 tells me I've got to go out. My change in x is going to be 3. What value of 3? So I'm going to go out 1, 2, 3, 1, 2, 3. My change in y is going to be the absolute value of 4, which is up 4. 1, 2, 3, 4. Down 1, 2, 3, 4. And I have an ellipse. And if it was a hyperbola, this would be my slope box right there, right? And my branches would be going out. Since we're on our x, my branches would be going out here and here, right? They're all related. It's all the same thing with subtle little tiny changes. All right, let me see. So is this a parabola? No. Is this a hyperbola? Yes, because of the negative sign. So I know my center is +3, -2, +3, -2. I move out on my x's by 5. Wait, guys, give me a second. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I move up 2, up 2, down 2. There's my slope box. 30 more seconds. My asymptotes are simply drawn through the corners of the box. That one's a little bit off. My asymptotes go through the corners of my box. Since I've got the x first, there's my branch. I've got one more to do. The rest of you can leave quietly, but I have to show you that this is a parabola. Can you tell me why it's a parabola? Only one square, so if I multiply everybody by 16, I will get my equation for a parabola. Good. X squared plus 4y equals 16. If I move my 16 on this side and the x squared on that side, I would get 4y minus 16 equals -x squared. I don't want a negative there, so I change everybody's sign. You're very welcome. Yes? Guys, that means you're going to have double homework tomorrow. So.
I'll take it. I'll take it.
All right, you guys, I'm going to have to put out a reminder right now.